So as soon as you start watching the video, then you are going to record those data into your in the table in your lab notebook. Okay, perfect. You know what to put on the left of the table if we didn't watch the video. From the procedure on the left side, from the procedure. For example, when you are watching the, when you read the procedure and it's telling you that part of the procedure is measuring the mass, or it tells you, let me go over the procedure for you, and then I would tell you what to look for, because I want to make sure that for other experiments you're getting the same. So the actual experiment here starts with, these are all theory. So the actual experiment, it says the experiment. So this is the experiment, okay? Separation and purification of the solid by recrystallization. This is the chemical reactions that you're going to perform. You start with aniline and then add acetic anhydride. It's going to produce acetanilide plus acetic acid. Because after the reaction, you might have leftover of aniline, acetic anhydride, and acetic acid mixed with your actual compound that you're concerned about, which is the acetanilide. You have to recrystallize your sample. So you are doing recrystallization because you don't want these impurities here. Everything else is going to count as impurity. So the procedure for the experiment, because the title here, it says this is your experiment that you're doing today. And the procedure for the experiment, it says to measure 4 milliliter of aniline. So you're measuring 4 milliliter of aniline, that's your reactant. You need to know how much of the reactant you are using, because later on you want to calculate the percent yield. Or at least if you don't recognize it now, when as we read the procedure, you would recognize you need to have the mass of reactant, because based on the mass of reactant, you want the mass of the, find the theoretical mass for the product, which is the theoretical yield or mass of the product. So 4 milliliters of aniline, that's what you are using, right? And then you're adding 30 milliliters of water. These are not major data, the 30 milliliters of water. These are the solvents, and the size of the flask you don't have to write. And adding 5 milliliters of acetic anhydride. It's not the data that you're collecting. This is the procedure, but you do need the 4 milliliter of aniline to do your calculation for later. And you are going to add acetic anhydride with the 30 milliliters of water. You're going to shake it well until the crystals form. So it says until solid crystals are formed, and you're recording your observation. The crude acetanilide, so that means these crystals are formed here, and step 3, that's not pure acetanilide, is a crude product. The meaning for crude product, it means that is the product that is just formed and has not been purified yet. Now it needs to be recrystallized. Okay, so you are doing the recrystallization of the product. Adding water as the crystallization solvent here. You are going to heat up to the boiling on a hot plate using boiling chips and all that. Then you are going to remove its flask and put it on the side to cool it to room temperature. When the crystals appear, then you place in the ice to complete the crystallization. So you're going to follow the procedure. Here, it should say that you are going to dry your sample, okay, after the filtration. It says pre-weighted labeled watch glass, okay, pre-weighed labeled watch glass. What does it mean? It means that you are going to weigh, you're going to label a watch glass and weigh it. So these are the numbers that you're going to record. Place in the preheated oven. When the crystals are completely dry, determine the melting point and the weight. So you're going to determine the melting point and the weight. So if you're determining melting point and the weight, those are your data that comes from this procedure. Okay. Then you want to calculate the percent yield. In order to calculate percent yield, you need to have the mass of the reactant. So that makes this formula leader important because that's your reactant. The calculation for percent yield is based on this chemical reaction. You have your reactant, you have your products. The acetic anhydride is the excess compound because it's approximate number, and the aniline is your reactant, that's your product. So in order to calculate percent yield, you need the mass of reactant and mass of product. Well, your reactant here is liquid, and if it's liquid, you need the mass of the, you need the volume for reactant plus density for the reactant. Using the volume and density, you can find the mass for the reactant. Mass of the product, you have to determine it. So it's a powder. You cannot pour the powder on the balance pan. You have to place it in a watch glass and you weigh it by difference. So when you know, I can understand for experiment 3 because it's huge volume of theory, because it has to cover everything, how to do the recrystallization. And why recrystallization is all of a sudden so important, because most of the experiments that you are doing, when there's a chemical reaction involved, your product, if it's solid at room temperature, it needs to be recrystallized. If you have like 2 or 3 experiments that you have to do distillation, distill the product to purify it, you have 80% of the time you have a solid that you have to do recrystallization. So the theory is covered in depth, and then after the theory it says, okay, now the experiment, and then it says now the procedure. So if you read the entire document for experiment 3, then you should be able to separate what is actually done in the lab, or what part of the experiment is like the body of the experiment for today's lab, even though it's labeled, you know, but still when you read the entire document, you will figure that. And then from the procedure, if you be patient and read it carefully, you see that it's telling you to determine the mass, to determine the melting point. So it's not just, you know, theory. When you have the mass of the reactant, because I'm sure this is a question, I'm going to answer it now. To determine the theoretical yield, you are going to need the mass of the reactant. In this case, your reactant was liquid. So Google the density for aniline. If the density for aniline is not given here, no, it's not given. So you have to search for density for aniline, because your aniline is pure compound. And then use the 4 milliliters times the density, that gives you the mass for reactant. When you have the mass for reactant, you change the mass to moles of reactant. How do you go from mass to mole? Is using molar mass for reactant. And when you have the moles of reactant, they use the mole ratio. Mole ratio of what? Ratio of product over the reactant. This reaction equation is balanced. You have 1-to-1 ratio. So 1 mole of product over 1 mole of the reactant can be used in this ratio. Mole ratio of product over the reactant. So you are going to convert the moles of reactant to moles of product. You need the mass of the, or grams or mass of the reactant. Volume is given, multiplied by density to get the mass. When you have the moles of product, you multiply by molar mass of the product over 1 mole of the product to get the mass of the product. Mass of product or gram of product is the same thing as theoretical yield. Percent yield would be actual over theoretical. Okay, actual over theoretical times 100, that gives you yield. I hope I answered some of the questions, and I'm going to ask you some questions at this point. Let me see if there is any questions first. Any additional questions? Okay, any questions? Questions? No questions? Okay, if there is no questions, I'm going to ask you questions. Okay, perfect. No questions about the calculating percent yield, because I just didn't talk about the table of result. I also talked about the calculation for theoretical yield, percent yield, and also I mentioned about the procedure. This experiment had covered a lot of theory, and probably you read the first 2-3 pages and you said, okay, that should be enough. But I don't blame you, really. For this experiment, I don't blame you. It's like a lot of theory, and it gets harder to find what's the actual experiment. I did try to label it at the end that this is the experiment, and I may have to make it a little bit more clear and separate from the theory, or give it like a unique title that the experiment part for this week starts here, something like that for next edition. Anyway, the next edition is coming up for fall, so I have to make some changes. That could be one of them. Going to make a note here, because I have other notes too. Okay, the crystallization. What are the steps involved in crystallization? Alexis or Kylie? One of you can answer that.
You want all of the steps that are listed?
2 major steps. I'm going to give you example. Like for distillation, we had 2 steps: distillation, evaporation, and then condensation. What are the steps involved in recrystallization?
Well, just that the solvent is dissolved. It's dissolved into the solvent. It's heated, and then it's allowed to. Then it's filtered, and then the crystals are allowed to form.
Okay. So dissolving sample or crystals in hot solvent and recovering the crystals by cooling down in ice, right? Those are the 2 major steps.
There's also a couple steps in selecting the solvent.
Yes, that is for selecting the solvent, yes, but in general, it would be that's like if I'm asking only for general steps, I meant the dissolving sample in hot solvent and then recrystallizing or recovering the crystals at cold temperature. Okay, very good. Next question. Mariah, and is Danielle here today? Caleb or Mariah? Could you tell me what is proper recrystallization solvent? First of all, let me know if you're here. Caleb, you're here? Caleb?
Yeah, I'm here.
Okay. Mariah, Yeah, are you here, Mariah? No? Okay. Caleb, could you tell me what's the characteristic for proper crystallization solvent? What is a good solvent for crystallization? What characteristic makes a solvent good solvent? Not yet, no. I have not. Jennifer?
Yes, I'm here.
Could you tell me what's the characteristic for good solvent for recrystallization or proper solvent for recrystallization, please?
Is the one which the product will be very soluble at high temperatures?
The sample would be soluble at high temperature and?
But it will be slightly soluble at room temperature or lower.
Not soluble at room temperature or very low solubility at room temperature or lower.
Mm-hmm.
Perfect. Okay, I wrote the note to myself, hopefully make it more clear. What about impurities? What should happen to impurities? With respect to impurities, your solvent how should your solvent act toward the impurities?
So really quickly, just to go back a little bit, the most important characteristic for a good solvent is that the solvent and the solute don't react with each other. Other than that, when it comes down to impurities inside of the solute, you wanted to cool it down gradually in order to not have the impurities in the solute when you recrystallize it.
Okay, so a proper solvent, what's the characteristic for proper solvent toward impurities? So how would the impurity behave when you heat up the solvent or cool down the solvent again, or the solution?
The impurities would separate from the solute in high temperatures.
Okay, very good. Anyone else? Any other insoluble at high temperature or soluble at low temperature? Okay, that's very good. Perfect. Who was okay, Ashrana. Yes, your sample should dissolve at high temperature, but should not dissolve at low temperature in the proper crystallization solvent. But impurities, either, so you have two types of impurities. Either they are not soluble at high temperature, that means they don't dissolve at all, or if they dissolve at high temperature, they also stay soluble at low temperature. So just like when Sammy said, when you cool down the solution, it's not going to come back to crystals. The impurities would stay in the solution. So they should either not be soluble at high temperature, and that's obvious. If it doesn't dissolve at high temperature, it's not going to dissolve at low temperature. That's one class of impurities. The other class of impurities that is known as the soluble impurities, they dissolve at low temperature. So when you dissolve the sample at high temperature, and you cool it down, both of the sample and impurity, it's soluble at high temperature, but when you cool it down, your sample, which is not soluble, it comes back to crystals, but the impurity would stay in the solution. So you have two types of impurities, and your solvent should be good enough. And that's for the design of the experiment. Today, we are not working at selecting the solvent. I only covered the theory, so you know how the solvent has been selected. That could be another experiment on its own to select the solvent. But when you select the solvent, it should be a solvent that it either doesn't dissolve the impurities, or it doesn't, it dissolves, but it doesn't recover. You don't recover it later. So when that's a good solvent, that it counts as the good solvent. If you look at this diagram, also explains some of the, it explains the entire basically steps for the recrystallization. You have your crude sample, and your crude sample, it contains soluble impurities and insoluble impurities and good stuff meaning that is your compound. Okay, that is the actual sample that you want to recover. The black dots here, these are soluble also. These are soluble these are soluble impurities, because when you see in the hot solvent, they dissolve, everything dissolves. But when you cool it down, the white dots, which is called the sample or good stuff, it comes out in form of crystals, but the impurities would stay in the solution. And these are some of the steps with some explanation here. There's a detour down here about hot filtration. Now, Kylie, can you tell me, when do you use hot filtration? When would you use hot filtration? Should you use filtration in Kylie and Elizabeth, the two of you can, you know, think about and answer the question. And Anam also can help. Under what conditions should we use hot filtration? Did you post the answer? Oh. When a solid, so Cassandra answered the question, when a solid contains impurities that are insoluble in the crystallization solvent. So if it's insoluble, or when the impurities are insoluble, when you say insoluble impurity, what it actually means that those type of the impurity did not dissolve at high temperature. So when the solvent or the solution is at the boiling point or hot, if you see particles, that means that those are impurities, because your sample should have dissolved before the boiling point of the solvent. So if you see particles, solid particles, those impurities need to be separated. And that's the time that you are using hot filtration. Can you tell me, why does it have to be hot filtration rather than gravity filtration at room temperature? Why does it have to be hot? What is hot filtration? Hot filtration means the solution that you want to filter is hot, still, you don't let it cool down. Very good, Ashana. Very good observation. And also, you are putting the flask with the funnel and the filter paper on a hot plate with some solvent. You heat it up. You make this system hot before you put the hot solution in. So my question for all three of you was, why do we have to have hot filtration? Why can't we use this system at room temperature? What will happen? How would that affect the result of the experiment? What's the purpose of the hot filtration? Again, is to remove the insoluble impurities only, right? This is just to remove the insoluble impurities only with the gravity filtration. Because when you want to save the liquid, we use gravity filtration. When we want to save the solid, we use vacuum filtration. If you put the hot solution through cold filter paper, as soon as it touches the cold filter paper, it's going to be shocked and crystals are going to form. This is known as premature crystallization, as Ashana mentioned. Premature crystallization means crystals form, but they form in a place that we don't want it. We don't want crystals to form in the during the gravity filtration inside the filter paper, because the purpose of this gravity filtration is just to remove impurities. So if our crystals form here, the stem of the funnel, you see this funnel is like a stemless? Yes, you're right, Tarek. If the crystals form inside the stem, they clog the funnel also. But we use the stemless funnel here. It's a good observation. So we can't use cold system to put the hot solution because we get premature crystallization. So we do hot filtration to make sure that crystals do not form, crystals are sampled, do not form inside the filter paper. So when we have the solution, we are going to cool it to room temperature and then place in ice. If we don't see insoluble impurities, that means if the solution is hot and you don't see any particles, it's clear solution, you just go straight. You don't detour here, you don't use this. Because if you use it for no reason, you lose some of the product because you get some premature crystals here, and you can't avoid that often. So you don't do this unless it's absolutely necessary. My next question for you. It says here, cool down to room temperature before you place in ice. But can we yes, we are removing the impurities. At the same time, we are removing some of the crystals. We don't want to remove those crystals in this hot filtration. That's why it's called prematurely. You can't lose crystals with the price of removing impurities. So to avoid losing crystals, we have to filter it hot so we don't lose crystals, we only collect impurities. My next question, and who has not answered question? Many of you have not answered question yet, but okay. Valentino, can you tell me, Craig and Valentino, could you tell me why do we have to cool to room temperature first before we place the solution in ice? Can we put directly in the ice and get the crystals really fast? Or should we follow the procedure and put it the room temperature to cool it down before?
I believe while
Yes.
I was reading the lab manual, it said that you shouldn't place it in an ice bath so quick, because if the temperature goes down so quickly, you might impurities might be trapped in the crystallization process. If I remember it saying that.
Yes, that is correct. That is one of the reasons. Valentino, do you have another reason for it? Is there any other problem with fast cooling? That means you place the hot solution directly in the ice bath. We try not to do that. We leave it to cool down room temperature first. Tarek? Other problems? There are three problems with that. One is as it precipitates, basically, because it's a sudden precipitation, is not crystallization. Crystallization, it's like some naive, like takes time, you know, it takes time. The precipitation is like a sudden. Okay, sudden, pouring down. Everything comes down at the same time. So if that happens, it can trap impurities. So your sample is impure and defeats the purpose of recrystallization. It can trap solvent. If it traps solvent, it gets oily product instead of powder or solid compound, you get oil. And you don't want that either. A third problem is that when it gets, sudden precipitation, there's no time for beautiful, nice, large size crystals. So you get like powder. And filtration is going to be hard because small size crystals is going to is going to block the opening of the filter paper, and then filtration is going to be slower. So you want to make sure that you can actually give time for crystals to form. Yes. Okay, very good. So those are the problems. So if it says cool down to room temperature first, cool down to room temperature first before you place in the ice bath. Let's say you cool down to room temperature first, you don't see crystals, then you say maybe the temperature is not cold enough. You place in the ice bath and no crystals form. How can you induce crystallization? What could you do to get crystals? After cooling in the ice bath, you see no crystals. How could you get crystals? And anyone who has not answered question yet? Katania, your answer probably fits this one. Scraping the bottom of the, okay, or put seed of the crystals. Very good. When you scratch the inside of the glass, or you add seeds, or you do further cooling, that was another comment that you had, Katania, to increase the yield of the crystals. First of all, you want to make sure the temperature is very low. So you leave it in the ice for a while. And the reason for that is the cooler the temperature is, lower the solubility, and lower solubility means maximum recovery of crystals. It comes back to solid when it's not soluble in the solution. If it's soluble in the solution, if the solution is not saturated, then it doesn't happen. So seeding crystals is by using pure crystals, like few grain of the pure crystals, or scratching with the glass rod. Scratching with glass rod basically drops like molecules of the glass into the solution and acts as impurity, acts as a seed for crystals, and crystals forms over that. And if you do all of this with seeding and cooling and scratching, you don't get crystals. What could be the problem? What happens if you use too much solvent? If you have too much solvent, what could happen? Anifal, have you answered question? Okay, if the solution is not saturated, so you don't get crystals, how would you get crystals? What would you do to get crystals? Anifal, are you here? Have you answered questions?
Yeah, I did, miss.
You missed your class?
Okay, if you're here, good. Can you tell me how would you get crystals from solution that is not saturated? Okay, if it's too dilute to form crystals, very good. Then what would you do? It's good that you answered. I didn't remember. What would you do? If it's not saturated, what would you do? Lower the volume. You can't add more compound because it was a product of the reaction. So you cannot add more of the compound. because you didn't start from like 1 gram of a container. It was a chemical reaction. You did everything. So how would you lower the volume? Pour some out? That's not going to work, right? It could be placed in ice. No, if you put it in the ice, it doesn't affect the saturation. Oh, but it could, but we already did that and it didn't work. So you have to evaporate it. Evaporate the solvent. Evaporate the solvent to half and then let it boil until the volume is half. Then you let it cool to room temperature, then put it in the ice, and now you get crystals. If it's not saturated, it's not going to form crystals. It has to be, first of all, it has to be concentrated, and it should be concentrated enough to be saturated. And then when it's saturated, you cool it down, it will form crystals. Add another solvent that the compound is insoluble in. Yes, you can do that too. Or the crystals would be very smaller. It's not the crystals are smaller. It's just that your percent recovery is going to be low. You want maximum recovery. Maximum recovery, you want to make sure your solution is saturated, that you can get the crystals out of the solution by cooling it down. If the solution is saturated at high temperature, when you cool it down, it gets even more saturated, and then the crystals starts coming out of the solution. I don't know if you made any like hard candy or it's they have like a, or if you use it, it's let me bring one and show you. These are like rock sugar. Don't know if you see it or not. Basically, they make like a saturated solution syrup of sugar in water, and then they place this plastic straw or stirrer. This basically acting as a seed also. If they don't use this handle or the straw or stirrer, if you've seen the ones that are loose and not like this shape, they get piece of string in there, and then that string acts as the seed. So crystals form there. When you're talking about crystals, you see organized shape of the sugar is coming from the sugar powder. Now, if you don't cool it this down slowly, you would get like the size of the grain is going to be a size of sugar, not the rock sugar. Yes, yes. Calculation is based on aniline as a reactant and acetanilide is the product. So adding a stirring rod can increase the surface area and cause a seed to form. Yes, yes, it will. Okay. Next question. After you cool it down and you get your crystals, you're going to filter it using a vacuum filtration. You see, this is the vacuum flask and is attached to the vacuum. Apply vacuum. The shape of the funnel, it looks like gravity, but it is a vacuum funnel. It's just the Hirsch funnel rather than Buchner funnel, looks like it. So this is the vacuum filtration. The crystals are going to be collected on the vacuum filtration in the Buchner funnel or Hirsch funnel. The impurities will be filtered. Then you're going to wash this with cold solvent. Why the solvent that you're washing needs to be cold? Since we are kind of running out of questions, I want to make sure everyone answers questions. If you have not answered any questions, say it at this point and try to answer it. Why do we have to use cold water to wash, or ice solvent in general to wash, rather than room temperature? Solvent at room temperature. You don't want to melt it. Basically, not melting. You don't want to dissolve it, right? Because with the solvent, you are going to dissolve it, not melting with the heat, dissolving with the solvent. Okay, to prevent the solute from dissolving again. And the volume of the solvent that you are washing with, it should be kept also at the minimum. We try to use small amounts of the solvent. That's because the solubility is not zero with the cold solvent. It's just much lower. So if it's like 0.1%, if you use 100 milliliter, you would get 0.1 gram of it away. It dissolves. But if you use 10 milliliter, you get 0.01 gram of it dissolved. So the colder the temperature, the lower the volume of the solvent, less chance of losing the product that you have recovered up to this point. Okay, any questions? Did I answer all the questions that you might have had for the experiment? Do you have any other questions for me? The rock sugar. Here. Yes? Okay, let me call for attendance, and then I want you to watch the video. Tarek, Ashley, Deja. No, mass of deionized water you don't have to, because deionized water is the solvent, and that's quantitative. So no, you don't have to include. Rosie. Rosie. Okay. Ashana. Elizabeth. Jennifer. Alexis, thank you. Kylie. Caleb. Valentina. Caleb. Valentina. Okay. Ashley M. Danielle. Mariah. Okay, Mariah absent. Catania. Anifel. Anam. Sammy. Cassandra. Craig. Antonia. Okay. Just keep in mind, if you cannot attend your time, the 12:30, I'm teaching 8 a.m. and 3:30 p.m. on Thursdays. But you have to send me an email before that class, whichever class you want to attend, so I can send you a link for Blackboard Collaborate meeting, so you can join the other class in case if you have an emergency. So you could attend make up the missing lab in different time. Okay, very good. Any questions? No questions? Thank you. Have a nice day. And I have office hours 9 a.m. tomorrow in case if you have any questions.
Professor, I have a question.
Yes.
I was checking the first lab report that I did and the assignments. I was just going to look over it, see if I made any mistakes after I submitted it. And I noticed that my plagiarism was like 21%, even though I did all the work originally. And I looked.
That's 21% is fine.
Okay.
20% is fine. 21, I take it, but because all the data is the same.
Yeah, that's what I was going to say. It's because we all have the same data and we all have using the same terms like melt temp apparatus, ethanol. That's what it got me on. I was like so confused.
It doesn't really take the words, like if it's used in different order or different sentence, it doesn't take it, but the data takes the data. So if it's 20% or less, or around 20% is okay.
Okay, thank you.
You're welcome.
Hi, Dr. Mamari. I also have just another question in general. So,
sure.
So for the lab notebook for experiment 3 for recrystallization, I didn't necessarily have a chart, but I did list in the, after the procedure and everything, I listed the volume of aniline, and then I put blanks for density and the mass of alanine, and then I put a blank for the mass of acetanilide and the melting point of acetanilide, and a blank for the literature value for the melting point of acetanilide. The only thing that I don't have is the mass of the watch class, because I assumed that mathematically I would figure that out with, with the watch. Oh, okay. So is that fine?
Yes, as long as you have did you have the table, right? Did you draw the table?
I didn't draw a table. I just listed.
I want you guys to get used to just drawing that table. It's just the 2-3 lines, vertical, horizontal lines. Show me those lines, so you get used to this table, because data is not supposed to be recorded in paragraph format. But since you have the spaces, I take it this time. But please draw the table. Draw a table. It's organized in one place, and I want you to get used to using tables, because that's the format for the lab notebook and for lab reports.
Okay, thank you. I'll be sure to draw a table next time. It just wasn't very clear in this experiment, but now that I know what to look for, I'll start drawing tables.
Well, if you put all those into the context, then it was clear to you what we are measuring. Just those values, but put them in a format, please.
Okay, got it. And then I had a similar question to the previous person, where, again, my plagiarism was a little bit higher. It was like 25 or something like that. And
let's me grade it, because I don't just take points off. I open the document, I match with whatever is source is coming from, and then I check it for similarity in the, like, a paragraph or discussion or something in the what is it, introduction. So let me grade it before you get worried about it.
Okay, that's fine. And I know you have a lot of classes and you have a lot to grade, but when would we expect to have grades on the lab reports and the quizzes and the lab notebooks?
Did I grade at least for experiment 1, or I skip yours? Because I did grade for the 8 a.m. and 3:30. Did I skip yours?
I believe so. I think you only graded
Okay,
the.
it's my fault. I will grade, so at least you know how it's done.
Okay, yeah, that's fine. I think
I,
you only.
lab 1 grade is missing as well.
Sorry. Well,
I was just adding
I
that
will.
my lab is missing as well for the grade.
Sure. Uh-huh. No, it's for the class, it's not the person. The whole class is missing it.
right. I think we only have the grade for lab notebook 2, and we don't have the grade for quiz 1, the lab report for
I
1.
would grade the quiz 1 right today. I will grade the quiz 1.
That makes sense.
Um,
Thank you.
You're welcome.
Thank you, Dr. Mamari. I appreciate
You're
it.
welcome. You're welcome.
I'll probably see you tomorrow.
Okay, sure.
All right. Have a great day.
Thank you. You too.
Professor, I have a question.
Yes.
I was looking at the so you know where we turn in lab notebook 3, right?
Uh-huh.
And you know, usually like under it, it's supposed to give you the option for the lab report.
No,
Oh, it's not?
no. Lab report, I'm sorry. Lab notebook, there is separate assignment than the,
Oh, yeah, so I understand that it's separate, but I was saying that for some reason I don't have the option to upload lab report 3.
okay. Did you submit your confirmation number for purchase?
No, I didn't.
That's why.
Oh, okay. So what
Yeah.
do I have to wait? Hold on. Which class is this?
You have to purchase your lab manual, the ebook,
Uh-huh.
and submit the confirmation into the folder before they show you those.
So do I just like take a screenshot of the email or just like what? Sorry.
The confirmation, like when you order it, it gives you confirmation number, right?
Yeah, I'm gonna have to look for it.
Where did you purchase it from?
I'm pretty sure I purchased it from B.
You purchase from either, there are two choices, either bookstore or Vital Source, and they tell me, actually they send me the list of people who have purchased it, but not now. They would send it to me March, but then it's too late. So I
Oh,
want to submit it now to get the assignments visible to you, and then by the time is March, then I can actually match. But at this point, I'm just saying, if it was Vital Source, the instruction how to get the confirmation is given in the assignment, as well as the syllabus. If it's a bookstore, they send you an email with the
that
link.
was do it online when I did.
Okay, so go to the Vital Source, or please check the syllabus, find out how to get the confirmation. It's easy, like 2 steps, very quick, and
Okay.
get the, yes.
Thank you.
سلام آقا جان. آره ها کلاس هم همین الان بستمش. بذار ببینم. واسه